So let's start. I will use learning by example instead of explain the definitions. And this tutorial is made for someone who already program in another language, and it can be R, Java, JavaScript. It has the basic concept. If you want the full reference for the language, you can go to the official Python language reference here. Just a moment to shut down the noise here. Okay, and Google has also a style guide for programming in Python. You can access using this link. This style guide is for how to declare functions, how to write code, how to name things. It's a guide to standardize the way you write your code. Okay, Python has some main characteristics. First, it's a dynamic typed language. You do not have to do explicit declaration of types. It's interpreted, but today there is a JIT compiler to improve the speed of the code. And it can be programmed in a function or object-oriented way. It has support to namespaces and modules. And it was created with the intent to be very readable. For this, the language don't have a code block separated by characters. It uses a lot of space and indentation to separate codec blocks to improve the reading of the language, the readable of the language. Okay. So let's start. To know what variables or identifiers you can't use, you can use this command from Python, help keywords. It shows the list of reserved keywords, the keywords you don't normally use for defining variables or functions. Okay, it's possible to use it, but it's better stay away to avoid these strange errors in your code. Okay.
Marcos, may
Yeah.
I interrupt for just a second? Is it
Yes.
possible to do it bigger, the screen, because I can
Okay.
see? Sorry. Thank you.
It's better.
Yeah,
Perfect.
now it's perfect. Thank you.
Okay. Okay. And the statements and variables, variables names in Python can be any combinations of letters, numbers, and the underscore symbol. The only restriction is that you start it with a letter. In this case, it can be uppercase, lowercase, and after this start letter, you can use any combination of space, of underscore, letters, and numbers. For the separation of several words in a variable name, the recommended way is use the underscore, is the style guide for Python. Okay, some languages use the capital letter for doing this separation, but Python style guide suggests to use the underscore. So here we have some valid names, and these ones are not valid because they started with numbers. Okay, the statements can be any expression in Python or function calls, for example, or object calls. Here we have simple expressions, summation, multiplication. You have to be aware of the precedence of the operators. We will discuss this later. Okay. The first thing you do normally is create variables and assign variables. And variable assignment in Python works by using the equal sign. It's the usual way to assign variables. Other languages like R use the arrow, but Python use the equal sign. You can assign it to expression, to other variable, or any combination. Using operators also. The only restriction is that the right part of the assignment is a valid expression or statement. If you have a statement that needs to, it's very long to declare in one line. In other languages, you have the semicolon you use to separate statements, but in Python, we don't have the semicolon. If you want to create a multi-line statement, you have to use the inverted slash or the backslash. Someone called also the backslash to create a multi-line statement, okay? Now, after defining a variable, you have to know about the possible data types of the variables in Python. Python has a number of native data types as numbers, strings, bytes, booleans, lists, tuples, sets, and dictionaries. You see all these types except bytes because it's not very used. It is used by people who develop protocols and manipulate binary data. This is not the case for the majority of data science. Okay, the first data type is the number. And in Python, the number can be classified in several subtypes as int, float, and complex. The most of the languages use the int and float subdivisions, but Python has also the complex. Complex are complex numbers that are represented by a real part and an imaginary part. To declare a complex number, use the G or capital G to separate the real from the imaginary part. So here we have some examples of numerical variables. The first one is an integer. The second is a float. The float in Python is a 64-bit float. Here we have the normal multiplication. We can have in expressions some values using one type of flow of number and some values using other types of flow of number, and the pipe do the conversion from one type to another to reach the final type of the expression. Here is a declaration of a complex number. You use this syntax, the integer part, the real part, plus the number followed by j, and this is the imaginary part. Or you can use also the function complex that generates the same type of complex number. And you can use, for example, the normal operations to operate on complex numbers that you would use to normal numbers. If you run, you can have
Marcos, what is it, the brace and the F before the string?
Okay, I will talk about it in just a moment.
Okay, no problem.
It's used for formatting strings. Okay, we will see when we reach strings. And here's some interesting facts. Integers do not have a size limit in Python. It's a dynamically allocated type. So that there is no restriction of 64-bit or 32 bits. The more you need, the variable is reallocated to a greater use of memory. And floats use the standard 64 double precision values. The math functions in Python are supported by this library called math. And in Python, to import a library, we use the import statement, the import statement. In this case, we will import the math library to use. Okay, the first function very used in data science is the min and the max. The min and the max takes a list of parameters, or can be a list also, and returns the lowest and the highest value of the list. The list don't have to be a specific number type, can be any number type. Okay, in this case, min returns the smallest number, that in this case is 1.0, and max in this other case is 30. Okay. If you want to round values, you can use these other functions. The floor rounds simply cutting off the fractional part. In this case, if you run floor on 3.777, you have only the 3. The sail rounds to the upper integer. In this case, it rounds to 4. And the round function rounds to the nearest integer. In this case, it's more than 3, more or equal to 0.5. You round to the upper integer. If it is less, to the lower integer.
Marcos,
As in this,
only
yes.
a question. I don't understand why sometimes you are using round something, okay, and
Yes.
some other times you are using math dot floor, for example.
Yes, but round, it's called an implicit function. It's already defined in Python. You don't have to import it from any library. And these other functions, floor and sail, they are part of the math library. Okay. When we use the function without import anything, it is part of it's already part of the core of the language.
Okay, so it's like a base package.
Yes, it's imported by default. You don't have to worry about it. As
Okay.
as here, the print is also a base function. It's already loaded with the language. You don't
But
have to.
when you import, in this case, in R, for example, you import a library, and after you don't have to call the library again. I've seen that in Python it's not the same, because you have to call each time the library.
Yes, you import the library by its name, and its name is it's called a namespace. You use the functions and definitions inside the namespace. To use it, you have to prepend with the namespace. You can also do something like this. For example, import math as m, and here you can just use m to simplify. This way, you can import these libraries as the alias you want to avoid collision with several libraries, for example.
Can I say something here?
Yes.
Yeah, Julian, we can do the same thing in Python as well. If we write from math import star, then we can just write floor. We don't have to write math.floor or m.floor.
Yes.
But as he said, it's not
recommended.
do that, because maybe you have two floor functions. If you import numpy and math, then both of them, I think they have a floor function. So they will collide. It's not good in Python.
Okay, so you can use the floor, and it's the same as in R. Okay. And if you don't use a floor, see floor. If you don't use from, you have to write math dot something.
Yeah, it's always better, because you know this function belongs to math, not numpy. So.
Okay. Here.
Okay. let's continue here. There is also the string type. Strings are represented enclosed by both single or double quotes. In this example, the string is I'm a string, it uses single quotes. And to represent a single quote inside a string with that is defined with single quotes, you have to escape it using the backslash. In this case, you use the backslash before the single quote inside the string. If you are using the double quotes, you don't have to escape it because it would not end the string. In this case, if you have a string that will use the other quote type, generally you choose this based on what you have inside your string to avoid escaping. You can use both types of definitions. Okay.
The difference between the single quote and double quote, I don't know if there's a difference.
No, I don't think there is a difference. I never saw anything about it, a difference.
Okay.
If I have a string that would take multiple lines, you have this option to declare it using a triple double quoted string. Then you start your string. Oh, okay. You start your string using multiple lines and end it with a triple double quoted string. Okay. This is what you have asked. This is new in this for the new versions of Python. You can format strings in a more flexible way using the f prefix strings. Before the string you attach this f, and then you can use this syntax using the symbols and insert variables inside your string. In this case, I started with I don't know how in English we call this symbol bracket. No, it's not bracket.
Brace.
Okay. You can start expressions with brace, enclose expressions with brace, and the values of the expressions are calculated and attached to the string in execution time. You can also use a syntax that is similar to the C++ printf or sprintf. In this case, the syntax is used to format the floating numbers to two points after the dot. In this case, it's a floating number because it is a f with two positions of the point. And this is the two main ways to format strings. Use the f before the strings, or use the string and use the dot format method. And inside the string, you do the codification of how the string should be formatted. And inside the parameters of format, the expression that will be converted to the format declared here. If we will execute this, you have the floating number formatted to 2 points of the point, two digits after the point. Okay. The string has also some other functions like methods. The string object like upper and lower to convert it to uppercase and lowercase. It's very standard. And to manipulate strings, you normally use the index operator. That's the brackets here and the brackets that two points here. Operators. This is called this one is called the range operator in this case. So this is it. This is an example where this is a string example, and here you have the index for every character of the string. normally the string starts with 0. For who programs in R, this is a change. In R, the arrays, the lists indexes starts with the number 1. In Python, as in C or Java or JavaScript, it starts with the 0 index. In this case, the 0 index is the T, and every new character you have to increment the index by 1. You can also index the string using negative numbers. In this case, the -1 starts at the end of the string, the last character, and it's increased to the start of the string in this case. For example, if you do str of 0, you have the T. Str of -16, you also have the T, and so on. And this is another syntax, is the range operator, that you specify the range of the string you want to get. In this case, you specify the start index and the last index that it's not included. So in this case, it will include the 0 to the 3 position. In this case, for example, 0 is T and 3 is S. And this is what we have here.
Marcos, but in the case that for example, I don't want only the third character.
Yes.
For example, I don't want some other one, the T or something else. So in general, because in R, for example, you can say okay, str -3, for example. But in this case, -3 is something else. So how can you do it in Python?
The third character, as it starts.
To remove the third character, only the third character.
Remove? No, you don't use this operation to remove. You use it only to select, to do a substring of the other string. To remove, you have to use other stringy functions as replace or.
Yes. But if I want the same string but without the third character.
Now you have to do something like this, for example, 0 to 2 plus str 4 and so. Okay. You have to compose a new string without the character you don't want. There isn't a way to remove a character from a string, at least I don't know, using the operators.
Okay. Because I've seen that it's the same for the arrays in general. When I want to remove an element for an array or something else, it's
use the minus sign. Yes. But in Python, you don't do it. You have to use methods for the library you have chosen to see if there is a method, then do it. You don't have it built in the language. Okay.
Okay.
Okay, here's some other examples. You can use it with negative numbers to specify from -13 here to -15, not included. In this way, you have the E and the N in this case. No, -13.
Because it should be -16 to -13.
Yes. -13 is here. No, this is an example that you can't do the inverse order. In this case, the -13 is here and the -16 is here. So if you specify in the inverse order the last character and later the first character, you have a empty string in place. Okay. But if you do the other way, -16 to -13, then you have the piece of the string normally. And you can combine also negative index with positive index as long as the order is correct. In this case, negative 16 is the first, and then 4 is is later, and you have this. Okay. Another syntax is to use not specify the first index. If you do this, specify only the last index, you have from the start of the string, the string start from the 0 index automatically. And remember that this 4 is not included. This includes the 0 through to the 3, okay? To concatenate the strings, you use the plus operator in this case. It's very simple, okay? You can also, for example, multiply a string by a number. In this case, we have this string that is star star nice, and we want to repeat it 3 times and later add 2 stars to the end, and we have nice enclosed by stars in this example. We have operators of membership if you want to test if a string is part, so a substring is part of the string. In this case, the string is, I want apple pie for dessert today, and we want to test if apple is in string, in this variable string. And we have true. Pie dessert, you can see that is not true because there is this 4 in the middle here that is not in this string, so is not equal. And we have also the not in to test if a string is not in the string, and we have, in this case, banana is not in the string, it returns true. Okay. We can use the for statement to iterate in the characters of the string. Here we have a string, I am a string, and we want to print every letter of the string. The syntax of the for we will see a little later, but in this case, I declare a variable, and this variable will iterate to every character of the string and print it. In this case, it's printed one by line, okay? As I have said before, that there is some special characters you want to escape before introducing the string. If you use the double quotes to declare the string, you have to escape it before you use it inside the string. And for other escape codes, you have a link here where you can find how to escape special characters as symbols and other characters that you don't have in the normal keyboards, for example. The next type is Boolean, is used to declare if a variable is just true or false. You have only these values. In this case, I declare that flower is true and petals is false. And here I test expression, use the if statement. We'll see it a little later. And if the flower is true and petals are true, you have a rose, for example. You print you have a rose. If not, you print you have a kyatun. I don't know how to pronounce it. And as one is true and the other false, we have a kyatun. I have the not operator to negate the value of a Boolean variable. In this case, as flower is true, you have not flower, you have false. The numbers are automatically converted to Boolean. If a number is not 0, it is true. If a number is 0, it's false in this case. If you have, you can have also as using the bool function to do this conversion. If you do bool of 10, you have true, or you can do the double not operator. If you negate a variable and after that negate again, you have the same value, but declare it as Boolean in this case. Okay.
Marcos,
This is
what I've seen today is that the reason because, for example, bool of 10 is true is related with the fact that bool, not bool and these other operator are logical operator and not bitwise operator. Is it right?
yes. This not is a logical negation operator. If you do not in a number that is not zero, the number that is not zero is true. In this case, not true, you have false here. This number 0 is false. If you do not false, you have true. And bool can be used to convert it directly to Boolean. And you have this other option is equivalent to bool that is negate twice logically the value. Okay. The lists are the most basic storage value used in Python. In some languages, this is the function of the array, and in Python, it's called lists. So it's a sequence is stored as a fixed every value to a fixed position, starting to the index 0, and grows until the end of the list. In this case, use the brackets to create a list in an easy way. For example, here to create an empty list, you just declare an empty bracket here. To declare a list with some values, you separate the values with the comma. In this case, one thing interesting is that the list is not restricted to one type. It can be heterogeneous and support a lot of types inside the same list. In this case, I'm declaring integers and floats at the same list. To access the list, we use the index of the position and the bracket operator to get a value of the list. In this case, the first element is the number 1. So we have it when you do simple list of 0. Simple list of 3 is the last one of this list. This works exactly as string accessing string. You can use the minus 1 operator to get the last value of the list. It's not to remove a value of the list. It's to get the elements in the inverse order of the declaration. And we have the range operator here, the same way of use it to strings. But remember to be careful. The last index of the range is not included. In this case, we have only the 0 and 1 positions. 0 and 1. And we can do the shortcut if you don't need to specify the start. You want the beginning. You declare only the last element, not included. And this other case, we start from the third element and continue until the end of the list. You don't have to declare if you want the rest of the list. Okay, lists are not restricted to a single value. Here's an example. You can have a list with an integer, a string, a Boolean, a float, and another list inside one list. Okay, if you have the fourth element, you have this element that is itself a list. And we can concatenate the operator, for example, to access the sub-elements of this child list in this case. 4 is to specify we want this element, and 1 we specify you want the second element of this sublist. Okay, if you want to know the size of a list, you use the building function called len, and it gives you the number of elements inside the list. The same way with strings, you can create a list of repeated elements using the multiply operator. In this case, we have a list with a 0, and we'll multiply it by 5, creating a list of 5 elements being 0. Okay. And to modify a value of a list, use the same operator, but inside a statement. In this case, the position 0 of the zeros list will receive the number 1, and you do it using the equal sign. After that, you can see that the first element was changed by the number 1 you specified. If you want to add elements to the list, you can do it in several ways. Here we start a list with a new empty list. One thing interesting is that if you constructed an empty list and try to assign an element to a position, it complains because the list is always has to be always allocated with the size you want. If you want to adding a value to the list that is not in a position that is already declared, you have to use some methods as append in this case. So in this case, we start with an empty list. After that, we add a 0 and then a string called apple. And after that, you can do this, for example, after this position is taken, you can reassign it. New list. Okay, it works. One thing this is very strange for programmers in other languages is this list comprehension in Python. In the first time I encountered it, it was a bit confusing, but this is a way to build a list using an expression with interaction and or filtering. And the syntax works like this. This is a variable. It receives a list, starts with bracket and ends with brackets. You have an expression using a variable name, and then you have a for with this variable name in a list that already exists or is declared here. And you can use also the if with a fighter condition. For example, it's better to see working. If I want a list of the even numbers from another list, for example, the list is 0, 1, 2, 3, 4, 5, 6, and we want a new list of only the even numbers. So we declare this new list with the brackets. We declare a variable that will be the final element of the list manipulated by this for element. So this for creates this variable even number to iterate to each value of this sublist. And we filter with another expression here. For example, if even number, this is the modulus operation. It is used to receive the rest of the division. In this case, if the even number divided by 2, the rest of the division of the even number divided by 2 is 0, this number is even, then this element is added to this new list. In this case, 0, 2, 4, and 5. If you want here's another example. We want, for example, In this case, the odd numbers, because we are filtering here for the rest of the division is not 0. If I do just this, we will receive only the odd numbers, but we can also treat this variable as an expression. In this case, multiply by 10, we have a new list with the odd numbers multiplied by 10. It's a little, it's a little strange for when you see that for the first time. You don't need to specify this filter. In this case, we have another expression. We will multiply every number of this list by 100 and assign it to a new list. In this case, we don't use the if statement here, and you have all the elements multiplied by 100. Did you understand it?
But the filter can be more complex in general. If it's more complex, how do you understand what is the how to I don't get the point in the sense you I don't know I don't know how to do something in a more complex way.
Yes, but in general, it's used when you have to map some values from a list and do some calculation inside the list to create a new list. You can do it using a for as usual, and for each value in the list, you do this and assign to the new value of this new list. But you can shortcut this to one line of code using this list comprehension. It's just a way to create a smaller code. I don't know. Maybe there is optimizations on the compiler to do this in a better way. I don't know.
Can I say something here?
Yes.
Yes, this is usually very useful when it comes to importing files. So if you have a folder with different type of files, I mean image, video, something else, you can put a condition at the end that it should end with the .jpeg, for example, or MP4. So you just import the files that you are interested in.
Yeah,
Oh.
you can do it with several lines at the same way. It's just a compact way to do it.
Exactly.
Okay.
Okay, because in R, for example, you have a function that with an option that is called pattern, and you can write pattern equals to CSV, and at the end you don't need you read only the file with the CSV extension.
But this is built in the language. It is not included in a library. I don't know.
Okay.
In R, probably you are using a library to do this filtering. Okay.
Yes, exactly.
Yeah, R is more specific. I mean, they have some cool packages, let's say. Here you have to do it manually.
Yeah. Okay, let's continue. To remove elements from the list, you use the remove method. Okay, here I'm declaring this list and remove the second element, this 2. No.
Just a question, Marcos. If I understand, I can combine. Sorry.
Just to correct, the remove is not used with the index. The remove is used with the value. You remove the first occurrence of the value in the list. In this case, I'm removing the first one I found on the list and it starts with 2. Okay.
Okay,
please.
but I can I can, for example, write a sample list dot append something dot remove something else.
Yes, you can
Concatenate the different operation.
Yes, you can do a sequence of operations using append and remove, and this one is pop. This one uses the index of the position. In this case, I removing the last not removing. I'm getting the last element of the list in this case, And after that, the list does not have this element. It's remove it from the list, return it, and then the list don't have this element, for example. Okay. Let's run in this is in sequence. Remove orange there, okay, and then remove the last element is 300, and the list don't have orange and don't have 300 anymore. 300. Okay. Another way to remove an element uses the index position. You use the del operator. You can use the del and the variable name and the index of the position you want to remove the element. In this case, the third element will be 100 if we remove it. No, the third element is 5. If we remove it, you have this list. We can remove also inside a range. In this example, we remove the first and the second elements. And if you do this, we'll have only the fourth, the third and the fourth, the third and the fourth. Okay. You can search if an element is part of the list using the in operator. In this case, I declare a list with these fruits, and I want to know if this value orange is part of the list. Then I use the in operator. For example, fig is not in the list. It will be false. If you want the index, the number of the index of the element you are searching, you use the index method for the list. In this case, I will search the index of the orange's value. In this case, is the second element of the list, return 1. If you have, in this case, oranges appears two times, and the index will return only the first occurrence of the orange. This is the index 1. If you want the other occurrences, you can use the index with specifying the start index where the search begins. In this case, we will start the search using the third position of the string, and then it returns the index 5. 0, 1, 2, 3, 4, 5 is the last position of the string. Okay. Another problem for me, I don't like this behavior. If you try to find the index of an element that is not in the list, for example, bananas, several S, it will return an error. I don't like this behavior, but so if you have to find an element, you have to put it between this try and except constructs of Python to avoid the code to be interrupted in this case.
Is it the classical try-catch of Java and in general?
Yes, exactly. And if you want to construct a function that returns, for example, -1 or no or none, if the value is not present, you have to construct this function by yourself and enclose it in a try except construct. The libraries already has this, but the main language not. To combine lists, you use the plus operator. We have two lists here, and just use the plus operator to concatenate the lists. Another way is to use the extend method of the list. In this case, the list 1, I use the extend to concatenate another list at the end of the first list, the same way. I think this one is more understandable, more clear.
And append is not the same as extend.
You append one element. Extend, you are extending with another list.
Okay. So you cannot append. No. Yes. Okay. Right. Yes.
Okay. Some other user use functions. This one is very interesting. It's all that returns true if all elements of the list after coerced to true, after coerced to Boolean are true. In this example, the first is true in Boolean. The second is the number 10 that after coercing to Boolean is true. And the third is the string origin that after coercing to convert it to true to Boolean is also true. In this for this the returning of the all function will be true because all elements of the list are true. If you add to this list a false element, then you have at the end a false, and we will repeat the function. We will get a false. This is the all function, but we have also the any function that returns true if any element of the list is coerced to true. In this case, as at least one element is true, the any returns true. Another user function is the enumerate that uses to work with fors and other constructs that use enumerated types. When you create a list, in this case the 20 apples and 100, and enumerate it creates a new structure that is a pair of indexes and values. In this case, it starts with 0, the index, and the first value, and later the one index, the second value, and so on. And you can use it in a for to iterate to elements of this enumeration. For example, the difference here that the first variable you use in the for is the index of the enumeration, and the second variable is the value, the itten value. So in this case, you are iterating to this enum list, getting the index and the value and printing them. Okay, and you have 0, 20, 1 apples to 100. It's useful because sometimes you want to this kind of tuples with index and values in a separated way. The same way with numbers, with single numbers, you can use the min and max functions to get the minimum and maximum value of a list. You can use the sorted function to sort the elements of the list in ascend order or in descend order if you use this reverse equals true to the function. And you can also do a summation of the elements of the list. The next type is set. Set is a little different of lists because it's a immutable type in the way you can change the value of a set after the value is defined. The same way as lists, it can be used heterogeneous types. You can use ints, floats, booleans, and so on. And you declare using these brackets. No, not brackets. I forgot. Braces. Okay, you can use it.
Curly brackets.
Curly brackets. You can declare it with curly brackets. Okay. This way, I start a new set 1, and the difference here is every value of the set has a hash value associated. For example, the number 1 is hashed to its own number. The number 2, it's a number. But if your value is not an integer value, it's converted to a hash of numbers based on an internal function of Python. In this case, 3.5 is converted to this hash. Apple is converted to this hash, and this other list is converted to this other hash. these hashes are used to avoid the repetition of an element, because as a main feature of a set, each element must appear only once in the set. You can have the same element twice. So this hash mechanism is used to avoid the repetition of an element in the list. Okay. If I want to, for example, here add another one, you can see that we have only one version of this element declared. It's not repeated. Another way, you can declare using the curly braces, or you can declare it using this another format that is the set as a function, for example. Okay, is another way to declare a set. And in this case, we have 10 twice, and it appears only once. To add, yes.
But for what reason do you want to use a set in general in Python?
To avoid, mainly to avoid repetition, and to guarantee that an element can be changed before after declared. In some situations can be useful, but it's restricted the possible use, I think. If you use a list and you, for example, if you are iterating to a list and adding values to another list, if you don't want repetition, you have to test if the new element is part of the list that you are adding or not. Using sets, you don't have to do this verification. Is free in this case. To add elements to the list, you can use this add method for the list. Here you created an empty set, and then you added another element to the list. You can also add several lists inside the list using the update command that adds multiple elements to the list. In this case, we have two multiple elements to the set. In this case, we have two lists of elements, one list here and another set here, and we want to add all these values to the new set. In this case, after doing the update, we have the new set with all the elements from these lists and sets, avoiding repetition. If you want to discard an element of the list, you use the discard method, as here. If the element is not in the list and you discard it, there's no problem. Nothing happens. But for example, if you remove the number 1 in this case, and after that you try to remove it again, we have an exception. And if you want to have an exception, you have to enclose it by a try except block in this case. If I remove this block, we'll have to an exception raised, okay? Unexpected indent. You can use the set operations as in math, union, intersection, difference, and symmetric difference. For example, you have these two sets, apples, bananas, apples, and oranges. The union of the two is use the pipe operator to create a union, vertical bar. The intersection is the E operator. So the elements that are common to the two are apples in this case. The difference are the elements that are in the first but not in the second, and the only element that are in the first but not in the second is bananas. And the symmetrical difference is element that is not common to both lists in this case. And we have bananas and oranges. Okay. All right. Can we continue to tuples?
Yes.
Okay. Tuple is another immutable collection of heterogeneous elements. It's very similar to the list, but the elements of collection cannot change. Okay. This is the distinction. The set are immutable, but you can add and remove elements from the set. In the case of the tuple, you are not allowed to change any element of the tuple. Once declared, it's fixed. In this case, I have a tuple of 1, 2.0, and orange. It's declared with the parentheses here, and you can access it by the normal indexed operator here. But if you want to change an element of the tuple, you can't do it. You have an exception. The tuple object does not support assignment. It's like declaring a list as a constant. You can change it after you create it. Okay. You can create it also with the tuple function. And it's another way to create it. And there's two other things you can do is count the number of elements using the count. The number of elements of the list is the len function, and count is the number of occurrences of one element in the list. For example, in this case, we have the two elements 2 times. In this case, it turns 2 times. And the number of elements in the list is the len 4 times, 4 elements in the list. The last type is the dictionary. That is a collection of key value pairs. The keys are declared before the semicolon and before the colon, and the elements are separated by commas in this case. We have a dictionary with the key IT for Italy, BR for Brazil, US for United States, for example. And the values are separated by commas in this case. Okay, we declared. And if you want to access any element, you can use the index operator, but without an index, but a key in place of an index in this case. Okay. If you try to access by index number, you also have an access error in this case. You cannot access by index the dictionary. But if you declare a dictionary with integers instead of a string as keys, then you can access using these new keys. For example, you have this list 1, 2, and 3. First, second, and third. If you find by number, in this case, you get second. If you find by 3.0, you have the third. But if you here declare 3 only, it tries to convert it to coerce it to see if an element exists in the list. But if you try to do something like, for example, 4, you have an error, a key error. You can declare the dictionaries are heterogeneous. You can declare any type inside the values. For example, in this case, we have another dictionary associated with a key. For example, product 1, the value is another dictionary with name and value. Product 2, another dictionary with name and value. In this case, we can concatenate to get a sub-product of the dictionary. In this case, I will search for the product as the first key, and then in the second dictionary, I use the key name, for example. Product 2 name, you have PS4, for example. If you want to check if a key exists in the dictionary, you can use the in operator. Okay. If you want to update a value in the dictionary, you do the normal assign with the key inside the index and the value followed after the equal sign. In this case, I will change the grape for the color of the grape to, in this case, as grape does not exist, it will be added to the dictionary. And we'll have a new entry with key grape and with value purple, for example. You can also do the update method to change in a batch several keys and values. For example, in this case, I will add orange, strawberry red, and grape violet. The grape here is purple in the moment, but after doing this update, we will have the other values with and the values that existed changed. For example, grape to violet. It is override. Removing elements from the list. Here we have the country list again. We use the del operator with the key you want to remove. In this case, I remove Italy and remain Brazil and France and United States. You can use also the pop method, is equivalent to the del operator, removing Brazil. And you can also remove a random item from the dictionary. If you don't specify a specific item, one will be removed randomly, in this case, pop item. If you want to clear a dictionary, you use the clear method. Okay. To iterate through a dictionary, you use the usual for, here declaring again the fruit colors, and we have the for with the key, and key is the variable we will use inside the for, and here is the dictionary we are iterating. In this case, I will print the fruit color with the key, and the fruit colors key as the value. In this case, we have the fruits and the values, banana yellow, grape violet, etc. Another way is to use the dictionary dot items that creates a enumeration but with the keys and the values. And here we can separate the key and the value, not just the key, as in this case. We use the key and the value, and inside the for, we use the keys and the values directly. It's equivalent to this form, but without the need to do a range operation inside the dictionary. As for lists, we can also have this comprehension.
Marco, stop a minute. Can you print fruit colors dot items? I want to see what is the output.
Yes.
So it's what is the I don't see the out. What is the?
This is a list because it starts with a brackets, And this inside the list there are tuples, yes. And
Okay.
when you do this, each value of the items, one value is this, another value.
Okay.
It squares this banana to key and this yellow to this.
Okay. Okay.
This is a standard way to get a value. For example, let me try another thing here. Yeah, creating. You can do this.
Okay.
Okay, this is the same thing, but in this case, these tuples are created by this function items. It's just another way to get the values directly in place of doing the arrange searching from the dictionary. Index key search.
Clear.
Okay. And we have the comprehension also for dictionaries. Here, first let me show how it's done this part of enumerate. First, we have this cardinal, that this is a list of first, second, third, fourth, and fifth. For example, if you want to create a dictionary where the first element is an integer 1 associated with first, the second element is an integer 2 associated with seconds, and so on, we have some options. We can do it with a for. We can do it with this enumeration indict, because as I said before, enumerate takes every element of the list and returns a tuple of starting with index 0 and the first element and so on. And you can convert it to a dictionary in the end. So after executing this, we have this 0 first, 1 second, 2 third, and so on. But it's wrong. I want to start with a 1, not with a 0. In this case, we can use this comprehension to do the trick. First, we enumerate the cardinal the same way we have done here. And then we do a for. This is the index, this is the value. And for the dictionary, for the key, we use the index plus 1, an expression. And for the value, exactly the value of the enumeration. So after executing this, we have the 1 first, 2 second, 3 thirds, and so on. Okay, this is another way to use comprehensions to do some manipulation of index or values in dictionaries, for example. It's very powerful because here you can put any expression. You can use also the if statement in the end to filtering. After you get used to this type of declaration, it's useful. Here is the list of operators. You can find the definition of each operator here. We have the bitwise operation, division, concatenation, addition, exponentiation, the two stars. If an item is part or not part of anything, the index assignment, the deletion, just the index, shift, bitwise shift, and so on. We have all the operation here. You can find the complete list of operator here in the Python documentation. Here is the operator's precedence. It starts with exponentiation, then negation, bitwise negation, plus, minus, multiplication, division. addition and subtraction, was bitwise operators, comparison, is or is not, in or not in, and ends with not or and. This is the lower this is the high priority at the end and the lowest priority at the start. Okay.
I think Mahabir has his microphone turned on.
Mahir.
Okay. Thank you, Mahabir. Hello, Mahabir.
Sorry, I'm now muting my microphone.
Okay.
Yeah, sorry.
Okay. Now we go to the statements. The if and else is declared this way. You have the if and a logical expression. It ends with the column, and after that you have a code block indented to the right. This is required. This is required. Every block of code you have to indent it to work on Python. If you don't indent it, you get an error, or worse, you have a program that not function as you imagined it would. For example, this is a Boolean expression. If a flag is true, just print flag was on. You can declare it explicitly, flag equals to true, or if you have only an expression, it tries to coerce it to Boolean in this case. The same result here. If 10, it's coerced to Boolean and it returns true. If 0, it's false, does not print anything. If it is a string, coerced to true. If it's an empty string, coerced to false. Okay. And these are the cases that are coerced to false: 0, empty strings, and the non value that is equivalent to the null in C. The JavaScript is it's a null value. You can have also the if-else syntax: if logic expression, code block, else code block in this case. Very standard. If 0 or no, 0 or empty string or none, it's false. Then we print none of them was true. Okay. We have also the elif syntax. If you have to concatenate several if commands in a row, you have an elif. If logic expression, code block, else if or elif logic expression, code block, elif logic expression, code block, and you can end it with an else statement. Here in this case, if 4 is greater than 5, elif else if 5 is greater than 5, elif 6 is greater than 5, and you have 6 is greater than 5. If else, none of these options. The for loop, the basic form is for variable name in and the sequence, and after that the code block here. In this case, we have this list. For E is the variable in sample list, prints E. You print every element of the list. You can use the range function to generate a range of integers. In this case, it starts with 1, and the last element not included is 5. It creates a range 1 through 4. You can also specify the step for each increment of the range. In this case, we start with 3. The last element is 0, and we do a step of -1. And if you want to break inside of 1.4, for example, you can use the break statement. We don't have this semicolon here. For example, in this case, when it's 1, the value of of I, it breaks the loop and prints only the 3 and the 2. If you don't have this, you go through until the 1. Okay. Because -1 is not printed because the range operator not includes the final value. It goes until the last element before the final value. In this case, the element is 5, it goes until 4. In this case, it's -1, it goes until 0, no, it's 0, it goes until 1. The step is -1. Okay.
Can you repeat again that part? I couldn't get it. Sorry.
This one or the first one?
The second one, the 1422. Yeah, that one.
Okay. In this case, we do a for, and we create a range of integers. Let me print this range of integer separately.
I got it. -1 there is step 1, right?
Yes, it is the step. Oh,
Right. I forgot.
okay. It
Got
created a
it.
range. It goes to from 3 to 0, not including 0. And each step, it increments by -1 in this case, okay?
Okay.
The while loop is while logical expression. While this logical expression is true, it repeats this code block. So in this case, counter is 3. While counter is greater than 0, print counter, and then reduce counter by 1. And we have 3, 2, 1. Okay. Okay. These are the basic statements. Now that there is 2 things to do: the functions and the objects and lambdas. Functions are code blocks that are declared to avoid repetition. They can be created without parameters, and then they can return or not a value or several values as a return. You declare it in Python, use the def keyword, the name of the function, and then parentheses. If you have parameters, you declare inside the parentheses. If you don't have, you use the empty parentheses. In this case, I declare just a function to print executing my code, and I call it 2 times. It's very simple. If you want to use parameters, you use def, name of the function, the name of the parameters, and you can return, for example, in this case, an expression of the parameters. In this case, I am just summing the 2 parameters here. Okay. You can return multiple values. For example, in this case, I have A and B, and I return A plus B and A minus B. And we use this syntax to get several returning parameters from the function. In this case, we will have 10 plus 20 for the first time, for the first variable, and 10 minus 20 for the second variable. If I print, you have this result. You can have a function with declared parameters like this, fixed or declared, or you can have a function with several variable parameters. In this case, I have a fixed value, it's A, and then this syntax of star, it's a name of a value. It creates a list for the rest of the parameters. In this case, for example, I print this dash, then I print the first variable, and then for each value in the list B, I print this other parameter here in the for. In this example, if I execute it, I have in this case only the first because the second one is an empty list. This other call, I have another list with one parameter. In this case, I have 1 and other parameter with the 2. And the third case, 1 is already defined, and 2 other parameters are inside this list B. Okay, other parameter 2, other parameter 3. It's a way to create functions that have a variable number of parameters. If you want to evaluate to have a default value, you can use the equal sign and the default value following the equal sign. In this case, I have a function named concat strings. Here I put a list of strings. And here we have the default separator. In this case, it's a blank space. So I create an empty list and I iterate from this list I receive. In this case, I create an enumeration, get the index, we get the value. If the index is 0, this is the first element, I just print the element. Else, if it is the second and fourth, I print the separator plus concatenated with the element. In this case, when I call it, I have this result. Here's I have 1, 2, and 3 separated by space. And here I have 1, 2, and 3 separated by 2 stars instead of this default space. Okay. You can also call function parameters by name. In this case, I declare another function sample function, parameter 1, a default value of 1, parameter 2, a default value of 2, parameter 3, a default value of 3. And here I just print the parameters. And when I call the function, I can specify the parameter I want to pass and the value. And the other parameters is used the default value for the other parameters. In this case, 1, parameter 2 is 20, parameter 3 is 3, 1, 23, and the other one, 10 for the first parameter. Because it's not declared, it goes by the position of the parameter. 10 for the first, the second parameter goes to 2, is the default value, and the third parameter, 30, we have this result. Okay. You can also return a function by a function. In this case, we create a function that returns a function that multiplies a number by another, for example. So we have create multiply by, and here in A, we have the value we want to multiply by. And we return another function that takes a parameter B and returns the multiplication of A and B. And we return this new function we've defined here. So in this case, I have a variable that I create, multiply by 100. I use this function, create multiply by, and pass this value that is 100. I pass it to the A. And then when I call this variable as a function, because it is a function, I pass the second parameter B, and it returns me the multiplication of A and B, in this case, 1,000, okay? 100 times 10, 1,000 is a way to create a function that returns another function. The scope of the variables inside Python, there is a hierarchy of declarations. The first one is the local scope. If I declare a variable inside a function, it is valid. It's valid only inside this function. For example, my var here is 1. I can print the value here, and I call the function, I have the value. If I try to print the my var outside the function, it's not declared, it's not defined, okay? In this case, I have another my var declared inside a function. I have another function declared inside this function. And this other function can access the var declared one level up. In this case, the function 2 can access the my var declared inside the function 1. As you can see here, it works. But if you declare a function outside a variable outside any function, it's a global function, and you can access it outside any function in this case. Okay. You can print. You cannot. If it is not declared in this function, it goes up. Search for this function, not declare, is go up and go to the global variables. Okay. Pretty standard. And there's only two other things, the class and the lambdas. Three, no. I don't know if we use C pandas today because it's taking a long time. We will decide.
It's not a problem. If you need some other time, we can finish next time.
Okay. The declaration of objects in Python using the class statement. All classes are suggested to begin with uppercase letter. In this case, a class called square. When we define classes, we can also define methods and a constructor to the class. The constructor in Python is declared using this underscore init underscore. It's a reserved word for declaring the constructor of the class. And the methods can be any other function name, normal function name. Another thing is specific for Python is this variable declares self. For every method or constructor, you have to declare this self variable that is a way to manipulate the instance of the class after the class is instantiated. And after this self, we have the other normal parameters for the constructor or for the methods. In this case, we create a square class, and for create a square, we define the sign length of the square. Okay, and we use it here in a very simple way. Square one is square, and passing the parameter 1 for the side length. For the constructor, we use the instance variable self to manipulate the variables of this class. In this case, I am declaring internal side length variable for the instance of this class, and assigning it to the side length of the parameter in this case. Okay, so this object square will have an internal variable of this colored side length and associated with this parameter we pass in the constructor. And we have two methods, perimeter or area, that simples calculate the perimeter of the area of the square using this internal variable, this instance variable called side length. Okay. If you execute this, you have square 1 of area 1 because its length is 1, perimeter 4 is square 2, area 4 because the side is 2, perimeter 8. If you want to create, in other languages, we have this concept of static variable of a function. Is a variable it's a variable that is the same variable for every instance of this class. For example, in this class rectangles, I can have an internal variable that is the number. Oh, there's a typo here. Of created rectangles, and each time I create a rectangle, I want to know how many rectangles were created in this case. We have the same a similar way of the square, declaring the rectangles. Instead of one side, we have two sides and two internal variables. But each time I create a rectangle, I want to increment this global value, this instance, not instance, this class value of rectangle. In this case, instead of self for the normal instance variables, I use the class name dot to access this class variable in this case. And here I am incrementing the number of rectangles each time a rectangle is created. Let's see.
Marcos, the created rectangles is a variable shared in by the different objects.
Yes.
But it's like a reference to the same variables in the memory. Is it
Yes,
right?
yes, it's the same. It's a static variable. It's the same allocated variable visible to all the instances. Okay.
Clear.
In this case, if I do create two rectangles and print, let me declare it first. Okay. If I create two rectangles, okay, I can have the area and the perimeter, but if I print the rectangle dot created rectangles, I have the number 2 because it was called twice, and it's a static variable for the entire class. Okay. Another interesting thing for objects in Python or classes is that you can overload operators in this case. And it's very useful to create, for example, adding elements to a list or multiplying the elements of a list, for example. You can use any Python operator and declare a method in a class that overwrite that operator for that class. For example, let me take the square class again, declared as before, but here we declare another method called underscore move that takes the class and a factor, and what it does is multiply the silent by this factor I'm given here. For example, in this case, I have square 1 is square of 1, square 2 is square of 2. I print the values, and I can do, for example, square 3 is square 1 multiplied by 3. What we have here, if I do this, it's called this method move in this object square 1. So square 1 call move takes the factor and do self.sideLength multiply by 3 and return self. In this case, when we do this, we have that square 3 is a sized version of x square 1, but the square 1 was also affected in this case. This is what you would expect. A square 3 is 9 and 20, but this one is you would not expect. A square 1 should not be modified. For this to work, not modifying square 1, instead of modifying the value of the object, you could just create another object, create a new square with the new side length multiplied by the factor. If you do this and run, then you have the expected behavior. You have x squared 3 is 3 times the x squared 1, but x squared 1 was not affected. Okay here?
Marcos, I didn't get the point this time. So what is the reason? Because doing squares 1 times 3, using this formula, you will call underscore underscore mul underscore underscore. I didn't get why. What is the reason?
Suppose you have a list, in this case, 1, 2, 3, and you want another list 3 equals list times 3. And you want a list, for example, where every element is multiplied by a value, for example. This is a way to override the normal operators of the language to construct a new grammatical, a new grammar, a new syntax for some libraries of objects. Pandas and NumPy use this extensively to avoid to call to call methods. They override operators of the language to make the things a little clear visually, for example, and to use the in expressions in an easy way, the operations. I don't know if you got it.
So mul is an overriding of a basic of the basic operation. So if you want to write mul I don't know mul p, it doesn't work.
No, it doesn't work. You have for every operator you have the standard definition in a string way. For example, I think you have to consult the language documentation, but for every operator there is a string representation for use the overloading.
Okay.
And the last thing, you have the lambdas. Lambdas are anonymous functions, are functions that we don't declare a name. Normally they are used for mapping and filtering operations in this case. In this case, for example, for mapping, we have a list and we want to return a list of every element multiplied by 2, for example. You have this function map, and this function map takes as values another function that returns this function map is a function that takes a function and applies it to a list of objects. In this case, for example, I take the function lambda, so I can explain.
It's like apply in R.
Yes, this function map takes a function. Here's the function. I have a function here, and here's the object to which the function is applied. For example, in this case, I have my list that is this list, and I apply this function here to every element of my list. And the result of this function is used to construct a new list. So instead of defining here def function, etc., we have the lambda declaration where you don't need to name a function. The function is declared. This is the parameter of the function, and this is the expression returned by the function. It's like defining, for example, def my function v return v times 2. This is the equivalent of doing this, but in a compact way. Okay. So
yes,
in this case, we have this list. We use the map to apply this function, in this case a lambda function, to every element of the list, and this result is converted back to another list. after I do this, I have the list multiplied by 2, element by element for the map function. We have also the filtering. Instead of map, there is another function called filter that takes a function, the same function, and takes the elements. And for every element of the function, it tests if the expression returned by the function applied to every element is false, it's removed from the list. If it's true, it's allowed to remain on the list. In this case, I have constructed a function, for example, exclude from the list. I have the list here, and I have the exclusions here. To test it, I create a list of fruits with several fruits, and I call this function I've created, exclude from list. The list is fruits, and excludes banana and grape from the list. I use the filter, and in the lambda function, I test if the value is not in the exclusions, it remains on the list. If it's true, it's filtered and do not remain on the list. In this case, after I call it, I have the initial list with these two values removed from the list. So this lambda is a short way to declare a function without a name, and its main use is for filtering and mapping of lists, dictionaries, anything you do these two operations of lists and maps. Okay.
So if you change 1 to 0 here, it will keep banana and grape and remove the rest, right?
If you want to change,
If you
what?
change the 1 to 0 in the filter.
1 to 0. Okay. Here?
Yeah, what's this one?
No, this is a L. This is a letter L. L is the name of the list. It's a variable.
Okay.
It's simple. Do this.
Yeah, okay. It
Okay.
seemed
Okay. It's confusing. Okay.
it's in this filter. It's cool. Nice.
And later we can do this Panda tutorials. No. You can do this exercise. And if you want, you can read these Panda tutorials from Kaggle before, and then we try the exercises from these tutorials to understand the basics of pandas. Okay.
The next time or now? What?
2 hours? I don't know. What do you think? I think it will take a similar time.
Yeah, it's already 2 hours.
Okay.
What do you? It's the same for me. So what do you think?
Yeah,
Okay.
and
Have time.